Okay, this is my first example of solving simultaneous linear and quadratic equations. So this is straight from exercise 3G and it's question 1C. The question says find the points of intersection of the line with equation 5x plus 4y equals 1 and the parabola y equals x squared. So as I mentioned in the notes above, when I want to do this, my first step is to get both equations to have y equals by itself and then to make the two equations equal to each other. Alright, so my problem here is the linear equation is all jumbled up with x's and y's on the same side of the equal sign. So I'm going to start with 5x plus 4y equals 1. And I'm going to rearrange this to make it 4y equals 1 minus 5x. And then y equals 1/4 minus 5/4 x. Okay, so now I've got my linear equation and I've got my quadratic equation. I'm going to make those two equations equal to each other. So I want equation 1 equal to equation 2, which gives me 1/4 minus 5/4 x is equal to x squared. Okay, my next step is to move all of my variables and all of my terms to the same side of the equal sign and make it equal 0. So I can rewrite this as 0 equals x squared plus 5 on 4x minus 1/4. Now if you want, we can start solving this equation with fractions. I don't really want to do that with fractions, so I'm going to times everything by 4. Now if I times 0 by 4, I've still got 0. X squared times 4, and I've got 4x squared, and then 5x minus 1. So it just gets rid of those fractions. It's a neat little trick. Okay, so I have to choose a method to solve this. Now I could factorize, I could solve using the quadratic formula, or I could complete the square. Now, just by inspection, if I start by trying to create two brackets with a 4x and a 1x, I would then have to have multiples of the minus 1 in the second bracket, and I can pretty quickly see that I'm not likely to get a value of 5x in for the middle term here. So I'm going to actually just skip straight ahead and use a quadratic formula to find out my values for x here. Okay, I'll just get rid of those lines. I'm going to get rid of that part because it's incorrect. Okay, so my x values using the quadratic formula will be minus 5 plus or minus the square root of 25 minus 4 times 4 times negative 1, all divided by 8. So then my x values, minus 5 plus or minus the square root of 25 plus 16 is 41, all divided by 8. Now this is a pretty messy equation. It doesn't look very nice and there's lots of things going on. But I do have my two solutions here. I've got my first solution, which is x equals negative 5 plus the square root of 41 on 8. And my second solution, which is x equals negative 5 minus the square root of 41 on 8. Now I could get an approximate answer using a calculator, but in the interest of this example, I'm going to work with these ugly values because I think that's something that some of you need to practice because you're hoping for high results and you need to be able to manipulate these ugly expressions. So we need to substitute these two values back into either expression 1 or expression 2. The easiest one for me to substitute it into, in my opinion, is going to be y equals x squared. So if I do y equals x squared and my x value is minus 5 minus 41 square root of 41, all divided by 8, and I want to square it, so then that becomes minus 5 minus root 41 squared over 64, which ends up equaling, now I've got to square the top bracket, and I can do this with expansion, so it'll become 25 plus 2 times 5 times root 41. So this is that binomial expansion, but not with algebra now, plus 41, because root 41 squared is 41, all divided by 64, which becomes 25 and 41 is 66. Plus 10 root 41 divided by 64. So that's my first y value, and that was when x was minus 5 minus root 41 on 8, and 66 plus 10 root 41 on 64. And hopefully I haven't messed up any numbers. So here's my first solution. For my second solution, I need to do y equals minus 5 plus root 41 on 8 all squared, which gives me minus 5 plus root 41 squared over 64. And then I can do the binomial expansion on the top line. I've got 25 minus 10 root 41 plus 41 on 64, which gives me 66 minus 10 root 41 on 64. And then finally I get my second solution, is x is minus 5 plus root 41 on 8, comma 66 minus 10 root 41 on 64.